It is Thursday, the 19th of June. I'm Jamie Fitzpatrick, sitting in for Adam Walsh. This is The Signal. And Sarah had it right. Today we are talking about health, science, viruses, misinformation, measles, COVID, all things related to vaccination. We have specialists here in the studio and on the line ready to dig into the issues around public health and public trust. So to get the conversation started, let's introduce the people that we have joining us, the specialists joining us for today's show. John Law is an associate professor of biomedical science at Memorial University. Thanks for coming in.
Thanks.
Rod Russell is a professor of virology and viral immunology, also with biomedical sciences at Memorial. He's on the line. Hello.
Good afternoon.
Natalie Bridger is a pediatrician, infectious disease specialist, and an associate professor at MUN, also clinical chief of infection prevention and control for the Eastern Zone of NL Health Services. Hi.
Hi.
Rob, before we go any further, I have to ask you, you were due in the studio, but I understand you're under the weather. Is it a flu bug?
It's one of the respiratory bugs for sure. I woke up this morning with that burny cough in the chest we all know, so I figured I shouldn't sit in a room and share air with yourself or anybody who knows anything about viruses.
Is this because you didn't get your shot last fall?
No, I don't think so. I think this is a different one that we don't have a shot for yet, but we might soon.
All right. We had to shore that up just to make sure we all have full credibility here. But thanks for getting on the line, even though you're a little bit under the weather.
My pleasure.
Before we go any further, we want to let all of you know out there listening, if you have any questions or would like to join the conversation, there are three ways to do it. You can send us a text, 709-327-8206. That's 709-327-8206 if you would like to text us. An email can be sent to thesignal@cbc.ca, or you can leave a voicemail at 709-576-5260. That's 709-576-5260. So there's a lot of places where we could begin the conversation, but let's talk about measles because it's been in the news so much lately. As of mid-March, Dr. Janice Fitzgerald reported that we hadn't seen a measles case in the province since 2017. Our vaccination rate is over 90% among children. Do we have anything to worry about? Natalie Bridger, I'll put that to you first.
Yeah, thanks for the question. I think that we do have something to worry about just because of what's happening in Canada and around the world. This year alone, there have been over 3,000 cases of measles, largely centered in Ontario and Alberta right now, but most provinces have seen at least one case. And unfortunately, there have been a couple of fatalities due to measles. So it's something that's keeping us at the edge of our seats here in Newfoundland and Labrador. We are lucky that we have a very high vaccination rate, but we're certainly not being complacent about it.
So who is at risk if they come into contact with a person who has measles? I understand it's highly infectious, but if I had measles as a child or if I've been properly vaccinated, am I at any risk at all? What is the risk to a community that is reasonably well inoculated against measles?
If the community has a vaccine rate of the mid 90s%, then that's a pretty good vaccine coverage rate to ensure that you won't get a major transmission event happening from person to person. But like anything, nothing is perfect. So there are certain folks out there who cannot be immunized against the measles virus. So babies who are less than 1 year of age, in general, don't get the measles vaccine. And there are certain people whose immune systems are compromised for one reason or another, and they either can't get the vaccine or even if they get it, they can't give the proper immune response to the vaccine. So there are people out there who, no matter what we do, are going to be at risk of getting measles and getting severely ill from measles. And that's why those of us who can get the vaccine really need to make sure we're up to date.
So it recalls the advice we were given during COVID when the vaccines were available, that one of the reasons to get vaccinated is not just to protect yourself and your family, but to protect the most vulnerable people in the community.
Correct. Yes. Yeah. And the same goes for measles. But as you know, and you've probably read, measles is the most contagious infection that we have in the world that we know
Okay.
about.
We're joined now by Dr. Peter Daly. He's a clinician and an associate professor of medicine and infectious diseases at Memorial. Thanks for running in.
Good morning.
Glad you were able to make it here.
Thank you.
I'm going to put the next question to you. We're talking about measles. It feels as if measles was almost eradicated up until recently. Was that an illusion?
No, I think it's very clear that measles rates in Canada went very, very low. And thanks to vaccine, measles was very well controlled. And it's only recently that we've seen measles start to increase again.
Okay. All right, John Law, let me put this to you. I don't know how much thought you've given to vaccine hesitancy, but it seems like the current measles outbreak is attributable primarily to that. Do you agree with that public perception?
Yeah, just like what Natalie has mentioned is that measles can be preventable by effective measles vaccine, but there's a lot of people that cannot get the vaccines, like young children or people with compromised immune system. So therefore, like the more people that can actually receive the vaccine is a help to establish a concept of herd immunity to protect people that do not able to get the vaccine. So it's important for people to have a high vaccine rate so that you can actually protect the susceptible population.
Do we have enough data to indicate that the outbreaks are taking place where the vaccine rate isn't as high as it should be?
Yeah. No, there's a true correlations with area that have dropped the vaccine rates. It's correlate with area that have higher cases of measles. And for measles, because it's a highly infectious disease, and so you really have to have a very high rate of vaccine coverage in order to have a good protection.
Okay. Rod Russell, I want to bring you in on this conversation. You can respond to anything that you've heard so far, but I did want to put this question to you. There is a difference between science and public health, right? Like public health messages have to be pretty basic, something you can put on a billboard, like the measles vaccine is safe or get your flu shot. Science and research are different. They're full of nuance and different studies done under different conditions with different results. So in that context, is there any credibility to concerns that some people have about risks involved in vaccination?
Are you talking specifically now about the measles vaccine or in general?
I'd say we'll say in general.
Well, in general, I mean, we know that some vaccines have side effects. Some are minor. Some can be serious. We know that, as mentioned already, some people cannot get the measles vaccine, and some people, sometimes 1 in a million people will have a very serious reaction. So there's always a consideration of risk, and that fuels the hesitancy toward vaccination, of course. But for some vaccines, we know there's almost no risk at all for people that can get them. If you have an intact immune system and can make a good response. So, for example, the hepatitis B vaccine is one of the best vaccines we have. It's lifelong protection, 2 or 3 shots, and that's it. You never need to get it again. We weren't that lucky with our first batch of COVID vaccines, but the measles vaccine, it's the greatest story we know of with respect to misinformation around vaccines, because there's a famous falsified study that made everybody think it was a dangerous vaccine, and that was disproven. But some people are still holding on to that theory, right?
So in terms of reluctance to get children vaccinated against measles because of some sort of perceived risk, you don't see any credibility in that at all for the vast majority of us?
No, not at all. That vaccine is safe, and all of like I said, the studies that gave or thought or provided some evidence that there was a danger around the measles vaccine were all proven to be false.
Okay. Given, Natalie Bridger, given our high rate of vaccination here in the province, what could a potential measles outbreak look like, or what circumstances could could that happen in, do you think?
Well, one thing that's been on my mind a little is our upcoming Canada Games event. So a mass event of young people gathering in close circumstances. So that's the sort of thing where you could potentially see some cases crop up. I once again am hopeful that we'll be protected by our high vaccination rates. But when we've got athletes coming from different provinces who may or may not be vaccinated, then that could be a potential breeding ground for cases.
They'll all be clustered together as well.
Exactly.
Right.
Yeah.
Okay. All right. Peter, you had your hand raised while Rod was speaking.
I was interested in giving a comment regarding vaccine safety because I think that's a big argument that the anti-vaccine group has against taking vaccination. And you're right that science and public health are two different things, and we talk with a kind of a science code that most of the population doesn't understand. So we need to make that very clear and interpretable to our users, which are our patients. We have a process of regulation of vaccine that requires randomized controlled trial in which a placebo is given compared to an active vaccine, and patients are followed for side effects or negative or safety problems. That was already clearly done in place for the COVID-19 vaccine, although the vaccine was very quick and very novel. It was well studied. And so we only achieve regulation once safety is very clear. So that means that vaccines do not reach people's arms until the regulators have received adequate evidence of safety. So although people may be concerned about safety, that is well taken care of in the scientific study prior to regulation. So that safety concern is really not a very valid concern regarding reason to refuse vaccination.
Okay, but let me put this argument to you as a pushback. It could be argued that people have a good reason not to place blind trust in science and healthcare, right? Prominent recent example, pharmaceutical companies are basically created the opioid crisis. Certainly that's what we've all been led to believe. Authorities and regulatory agencies failed to take any action on it until it was one of the most lethal addiction crises ever. So in some ways, is the mistrust in health authorities a little bit of a self-inflicted wound?
I mean, I think we need to preserve trust in science. Science is the process of evaluating evidence to make conclusions. I do hesitate when we talk about what profit does in terms of making some of these decisions. And when companies get involved and there's money involved, that's really no longer science, right? So, science is a process of evaluating that a new vaccine, diagnostic, or drug is safe and effective in a randomized trial. And that is still a trustworthy process. Go ahead.
Oh, thank you. I agree with everything Peter's just said, but I think, Jamie, you really hit the nail on the head with some of the distrust and mistrust of medical systems over the years. We, as a medical community, have gotten it wrong many times over the years. And so I think that we do need to have a certain level of humility when we're dealing with people who have questions about vaccines, because we don't know everything. I think that that the science is there. One of the tricky things about vaccines that's different from other medications is that you're giving an intervention to somebody who's well. So that requires sort of a higher standard of care, a higher standard of safety, and vaccines are held to a higher standard of safety in Canada than other medications.
John Law, I'd like your thoughts on this. I know you've worked with teams that have been involved in vaccine development. I mean, in those contexts, in those environments, does the humility exist and the second and third checks and balances exist to let people stand up and say, this is a mistake, we have to reverse course, this is the wrong path we're going down, this doesn't work, to basically be ready to scrap things when it's not going right?
Yeah, I think there's definitely a very high standard of safety concerns by Health Canada for any vaccine, like what Peter had mentioned. Even though where you see a vaccine roll out, there's already a lot of check and balances prior to that to make sure the vaccine is safe before you can roll out. And obviously, the vaccine also need to be effective before it can roll out. So there's a lot of check and balance and regulations that need to be passed in order for a safe vaccines to roll out to the market. And and I think one of the things that we already touched on is that we don't know everything. So it's one of the things that we constantly reevaluate whether we need to reformulate different recommendations. If things that after a massive rollout, you can actually see additional risk. You do see that the regulator changing their recommendations. For example, the one of the COVID vaccine by certain technologies seems to have a higher rate of complications. We do actually we educate the public in saying that we actually see with the additional data, we actually see a different kind of risk that we need to consider it. Because so the risk and reward calculation is constantly reevaluated, and so I think that's sort of what we want to communicate, that as actually there's a trust involved. We're not trying to hide anything that we don't know, or we try to hide anything that we know that we don't want to disclose to the public. And I think as the data coming, as a responsible scientist, we evaluate any new risks that we actually need to put into the equations.
Rod Russell, do you want to chime in on the issue of the broader question of public trust in science and medicine?
Yeah, I think following up on what Dr. Law said, the one example there is the RNA vaccines, right? We had a couple of different companies producing RNA vaccines, and they had, this was a brand new type of vaccine, right? We had never seen mRNA vaccines in humans. There'd been tons and decades of work done in animals, but the common public doesn't know about those studies usually. So, those vaccines appear to be very safe, but at some point we realized there was a myocarditis happening with the RNA vaccines. And there was, as John said, right, there was an adjustment made because in teenagers, for example, we heard stories coming out of the US where athletes had concerns about their potential to make, college basketball teams because they had some mild inflammation around their heart. And inflammation around the heart is a scary term to use when you're talking about your child, right? So I think, as John said, that's a great example of where the course adjustment and the honest disclosure of these things by scientists to say, look, this didn't come up in phase 1, 2, 3 trials, but we're seeing it now in a certain population. And in that case, the inoculum, or the amount of RNA that was in the shot, was reduced. And then there was a milder, the myocarditis was even milder. So, as you go to larger populations with these things, you might see, rare events that wouldn't have come up in smaller studies. And that's it. I think the credibility comes from from scientists and clinicians admitting that, okay, something came up we didn't expect, and now here's how we're going to deal with it.
All right, moving on, we have a question from a listener who wrote in to say, why do we still hear about vaccines and autism, especially on social media, I suspect? Why does this myth not die? I'm not sure any of us can give a definitive answer as to why this is still around, but let's start with you, Peter Daly. Is this an absolute 100% myth? Is this one case where there's no nuance and the science is clear?
I think it was really unfortunate that this ever was published, and the publisher actually redacted this article as flawed, and the doctor who published this lost their medical license. This was clearly not science. It was lies. And unfortunately, that gained traction, and that's become a kind of an urban legend, is that MMR is associated with autism in children, and that's not actually true. You look at the design of the study that produced that, it was not a high-quality scientific study. So it really was faulty evidence from the beginning. What happens we know misinformation gets propagated when the public has a kind of an anti-vaccine feeling or an antitrust against science. Small rumors go far, and people really take that up. So it's very unfortunate that that's ever been published, and it's really not the truth that MMR is associated with any autism.
Okay. Do you encounter this, Natalie?
Oh, yes. Yeah, I do encounter it. And to follow up on Dr. Daly's point, there have been multiple, much larger studies published since that flawed study, which have demonstrated absolutely no link between MMR vaccine and autism. I think the myth persists probably because of social media propagation and that sort of thing, but also the timing of when some signs and symptoms of autism appear in children kind of coincides with the time of the MMR vaccine. So it it does seem plausible, I'm sure, to a lot of families that there's a cause and effect there when it doesn't exist.
When it's just a correlation.
Exactly.
Right. I wonder, does it help if we can point to a particular source of the myth and say, as Peter just was talking about, here's the paper that was published that started this, and it was quickly debunked. I mean, does it help? I wonder if we're able to sort of get to the bottom of it, because that's where it started.
Yeah, I mean, I'm not sure making these scientific arguments really influences the public opinion, right? So it comes to what people listen to and what they choose to put their trust in.
Okay. I'm sure we'll talk more about trust as we go, but I'm going to back up the show a little bit and talk about what we might call some of the folk wisdom around vaccines and whether it holds true. So, John, let me start with this one. I think a lot of people will share this story. When I was a kid, the argument we were given about vaccination is that the needle introduces this tiny, very minuscule pinch of the disease to your bloodstream. Your immune system fights it back, and in doing so develops this fabulous army, that will push away and defeat any encounter with that particular disease ever again, and therefore you're safe. And then your immune system is all powerful. Is that truth? Very simplified. Is it wrong altogether, or is it somewhere in between?
I think it's somewhere in between. I think definitely in the early versions of the vaccine is usually a weakened virus or weakened pathogens that doesn't cause as much disease, and therefore you induce a immune response that you can actually overcome the subsequent disease that you actually see. We all heard about those childhood story of Jennings inoculate the cowpox virus, and eventually you're able to have immunity against the smallpox virus. That is sort of the versions of the classical vaccine story, that you have a weakened virus that educate your immune system. So when you actually see the real pathogens, you're able to have better chance of mount a successful immune system to overcome the infection. But like science, we actually increase our different methods of inducing these educations to the immune system. So now, instead of using a weakened pathogens, we can actually only use a small part of the pathogen. So sort of like the COVID vaccine as an example, instead of using a weakened COVID virus, we actually just using the outside of the virus to educate the immune system. So in this case, the component of the vaccine cannot actually cause any disease. This is just a one part of the virus that's to help you to educate the immune system. So the technology of the vaccine is actually also evolving field. There's many different technology we can use. I guess when we think about these, from the studio, I can see a lot of cars. So it used to be the Ford Model T. Now there's actually many different types of vehicle out there in the road. Some of them is actually very efficient. Some of them are actually very good. Some of them is actually very safe. So we have many more different technology to educate the immune system now.
Okay. Rod Russell, do you want to follow up on that? Are we in a situation where the Model T of vaccines is far behind us, and nothing that we would think of in layman's terms as a live pathogen is out there on the loose?
Yeah, that's again, that great job by my colleagues already. But I would just add there that it's not simple, right? If we wish we could say, okay, this type of vaccine is the safest and the best, and use that platform or use that strategy to make all the vaccines from now on. The truth is, we have many types, and this is something I teach to science students, to medical students, to graduate students, is that we have different, as John alluded to, right? We have different kinds of ways to make the vaccines, and some work better than others, and sometimes we don't even know why yet. One kind works well for one virus, but not for another, or for a bacteria, but not for another. So we're often just limited by the inherent characteristics of the bug that we're trying to fight. And then which vaccine platform or which strategy used to make the vaccine can determine how good the immune response it elicits is. So sometimes we would love to use strategy A, but we can't because it just doesn't work for that bug for some reason. So we have to use one of the older models of maybe not the Model T, but one in the middle. But at the end of the day, I think the important thing to know is that the immune system, the main job of the immune system is to recognize self versus non-self. So your immune system constantly surveils your body and says, this is me and this might not be me. And then the idea behind the whole vaccine strategy, for the public who might not know much immunology, is that you're basically giving a little taste of the bug to the body to say, look, this is something you might see soon or in a few years. And then that first response that your body makes is your primary immune response. But the point is then the second time your body sees it, it makes a bigger response, a faster response, a stronger response. So the idea is that when you actually do see the real thing later on, you'll react to it much, much faster and much stronger. And that's the whole idea around immune memory, which is why we do immunizations.
Okay. We'll move on with the discussion now because we're joined by Josh Rash, an associate professor at MUN's psychology department. He's on the line. Thanks for being with us today.
It's my pleasure to be here today. Thanks.
I'm going to take us back to when the COVID shot was first introduced. And I think in this province, we were able to avoid vaccine hesitancy, right? And get a terrific uptake on that. Why do you think we were able to do so?
I think there are a number of reasons that contribute to this. First, I just want to make the acknowledgement that taking a vaccination isn't a simple behavior. It involves complex decision processes where people have to weigh the benefits of the vaccine against the risks of contracting COVID, and also weigh the benefits and risks against not being vaccinated as well. I think that the government of Newfoundland did a number of strategic things that really helped with what I'm going to call vaccine acceptance. I don't like to refer to it as vaccine hesitancy, but rather trying to promote what we're trying to get people to do, which is accept and receive a vaccine. So when we think about vaccine acceptance, it ranges on a continuum. So it's important to know that there's probably about a third of the people, maybe more, who will readily get a vaccine and will do so with confidence. And then there are some who will have some indecisions. They may delay getting a vaccine. They may refuse some vaccines, but not others. They may have more questions about the utility and the benefits versus the risks of that vaccine. And then there's a small portion of the population who are just resistant with conviction to getting things like vaccines. So within Newfoundland and Labrador, I think we paid attention to the most important determinants of vaccinations. So when I think about this, I like to think of the 5 C's. So in order to facilitate vaccination, one must have confidence in the vaccine. So that's a level of trust in the effectiveness of the vaccine, the system itself that delivers the vaccine, and the motives of those who establish vaccine policies. We also have to combat complacency, which is the idea that the perceptions that risks of the vaccines are preventable and that the disease is not of a serious concern to those who are going to be affected by it. We also have to target inconvenience and make the vaccination convenient for those who are at the highest likelihood of needing the vaccine. And then we also have to really frame the appropriate messages in terms of the benefits and the risks to help people make adequate calculations about the risks versus benefit and whether or not it's feasible to take the vaccine. And lastly, we have to really create a collective shared sense of responsibility. So that's the extent that one is willing to protect others by getting the vaccination and protecting themselves. And in COVID, we saw that in terms of trying to get to herd immunity. So when we think about the strategy that Newfoundland and Labrador adopted, I think there are a number of factors that played into why our population was so acceptance of the vaccination. First, we saw proactive communication and the development of social norms. So there were constant radio and advertising campaigns saying, we are 75% vaccinated, help us reach 80% vaccination. We are 80% vaccinated, help us reach 85% vaccination. So in adopting this approach, we're really shifting the focus and attention on the desired behavior, getting that vaccine. And in doing so, we are really trying to avoid judgment, avoid labels, and avoid blaming people. We weren't calling members of our population hesitant to receive a vaccine. That, in fact, doing so might just entrench somebody in their own state of beliefs. So rather than doing this, we were trying to find out what people value and anchor ourselves in that value. Help protect the most vulnerable in your community, the elderly, the immunocompromised, by receiving a vaccination today. Beyond that, I think we saw messages coming from influential sources. So we had regular reports from the information by the Chief Medical Officer, Janet Fitzgerald, throughout the COVID period. And it's important to note that many members within our government in Newfoundland and Labrador were medical professionals. And so when we think about the messages that were being conveyed, we think about messages that came from people who understood the risks, appreciated the benefit, and hopefully gendered trust within the population. One more thing that I'm going to note that I think we did very well was making a readily available supply and distribution of the vaccinations. So vaccines were brought out to the community where people live so that they had readily available rapid access to them. Things like malls. We had wide open spaces that people could visit. They were free from harm. They were inviting. They had positive pro-social messages. Parking was free. Buses were available where needed. And I think that a number of these strategies, when pieced together, really helped us facilitate vaccine acceptance among a very large portion of our population.
So when you look at the continued conversation today on public health and on vaccinations, is there active research being done by people that involves sitting down and talking to people who are suspicious of vaccines, getting the essence of what's really on their minds so we can tailor a better message for them?
Absolutely. And I really appreciated what you said, because right now, really what we have to do is appreciate that we can't adopt a one-size-fits-all strategy to make people more accepting of vaccines. Really what we need to do is find out the motives and values of each individual person and tailor our communications to them to help engender more trust, to help them truly appreciate and understand the benefits and risks of getting vaccinated, as well as not getting vaccinated, to support their vaccination intentions, and to ensure that we activate the right emotions. So, for example, we want to activate positive emotions like hope, love, pride in being a Newfoundlander. Again, that was one that we saw during the COVID-19 pandemic. There was a shared sense of pride that we are doing some of the best work in Canada by having the largest proportion of our population vaccinated. So there's still research going on, ample research, that are targeting these types of influences when we try to shape people's behavior change around accepting vaccines.
Okay. Thanks so much for joining the conversation today. Appreciate it.
You're very welcome. Thanks for having me.
That is Josh Rash, an associate professor at Memorial University's psychology department. So what he was talking about in terms of messaging, I wonder, Natalie, I'll start with you. Does that sound familiar in the kind of conversations that you sometimes have with people?
Oh, yes, absolutely. And I loved the 5 C's. I'm going to think about that a lot now. I think the 6th C is probably encapsulated, would be culture. And I think that was a big factor in how well we did during the COVID vaccine time. But yeah, I think that I think that we do need to figure out what people's attitudes and beliefs are and intentions in order to modify behavior. And I think that the work that Josh is doing is absolutely going to help in understanding where some of the lack of confidence arises.
Peter Daly, do you sometimes find that you got into the business of medicine as a career, but now find yourself having to master the art of persuasion?
I don't think I'm very good at the persuasion, but I think it's interesting when we think about vaccine as a type of medication. So if I have diabetes and I take insulin, it's for the benefit of my health personally. I can take the insulin or I can not take the insulin, and I can have the good health or the bad health. When I'm taking a vaccine, I'm protecting myself, but I'm also protecting the health of another person. And that's a whole different argument, because then I'm doing something on behalf of someone else's health. And that changes that perception about vaccination. So some of this discussion back and forth, should we vaccinate, should we not vaccinate, has to do with personal politics. It also has to do with, do I prioritize the health of other people around me? And that's a complex question too.
Okay. Rod Russell, it strikes me as odd that we have this tremendous example of only a few years ago of how a vaccine can be rapidly developed and allow us to end a lockdown and reopen the world. People who aren't convinced by that maybe are out of reach?
Yeah, that's something I've spent a lot of time thinking about, right? As things unfolded, I mean, as a virologist who used to teach about the potential for, new pandemic viruses, we'd always said this could happen someday, this could happen. And it turns out that, in 2019, the day that I told the medical students that the biggest concern we have in the emerging virus world is the virus we don't know about. The day I said that in 2019, this virus was already circulating in Wuhan, China, and no one knew it at the time. So that's the point, right? That any day something could be circulating that we don't even know about yet, and we may have no immunity against it. So if you fast forward then, as somebody who's always been a champion of science and champion of research and vaccines, I believed that this was going to be a moment in time where there'd be increased and enhanced respect for science, research, and the people doing it. And I thought, I was not happy that we had a pandemic, of course, but I thought maybe now people will trust science more because we got vaccines fast. We showed that they were protective. We knew that, we saw death rates decrease. We saw severity of disease decrease. So I really believed this will change, the future, and more people will be accepting of vaccines, and some of the anti-vax theories would go away. So fast forward to now, and we see that hesitancy or acceptance, we'll say, to use our colleagues' reference, acceptance is lower now than it was a few years ago. That makes me sad. I'm disappointed, and I don't understand how we could have just gone through a pandemic, and 5 years later we're pretty much back to normal. And the vaccines helped, the public health strategies helped us get back to normal lives. So I'm surprised and saddened that people are less accepting of vaccines now than they were before the pandemic.
Mm-hmm. On a more optimistic note, I'm going to read an email that just came into the show. Thank you for presenting the vaccine discussion. As a nurse who has worked in pediatric oncology, occupational health and safety, and infection control, it's important to encourage public health measures. I am from Ontario, and I commend this province, by which she means Newfoundland and Labrador, for high MMR vaccine compliance rate. So we're not doing too badly, all things considered. Before we leave behind the discussion of COVID and what happened a few years ago, John Law, does anything spring top of mind when you think about what we might have learned from the experience of that pandemic?
Oh, there's a heavy questions. We learn a lot of things. I do think that just to relate it to the conversations we have, I think one thing we were excited as a science, we have many tools on toolbox that we can actually overcome diseases. This vaccine is really safe and effective, which is all encouraging. But also what we learn is that something good doesn't mean someone would take it. We need to initiate the communications and building trust, and sort of what we need to do is a sort of an ongoing process, and including now seeing back to some of the vaccine hesitant to previously we thought that was safe and effective vaccine. People now start to sort of have doubts that they personally already took those vaccines when they were younger, and there's obviously have no problems with that. And now because of the culture is slowly changing, and we start to question something that we previously thought that it was safe and preventable. So I think that communications and the vigilance need to be always around, so that we can actually enhancing that two-ways communications. I think that's something that I really take into heart. I thought the science is the difficult part, but then actually, like you mentioned previously, the persuasion part is actually important. And I think we touch on a little bit about this, is that everyone have slightly different concerns or questions. We cannot, because of that, and judge them, and we really need to respect their concerns and have that conversations to really kind of try to convince everybody to overcome the reasons that they're not doing what they're doing.
Okay. Natalie Bridger, I don't want to put anyone on the spot and hold them to every idea that might come up here, but I wonder, especially in your role in infection prevention with NL Health Services, do you ever give some thought to the COVID experience and how we might approach things different next time? I guess it depends on the situation, but still.
Yeah, I've given it a little bit of thought over the years. I mean, there are so many different aspects that could be handled differently, and I think that there are so many lessons that were learned about everything to do with pandemics and infectious diseases. But to Dr. Law's most recent point, I think one of the most important things was the art of scientific communication, and it is truly an art, and not all of us learn how to do it well. We don't learn it in medical school. Maybe they teach them now, but to convey messages that kind of relay the science, but also relay the human side of things. It's truly an art, and there are some people in the country who are really, really able to do it. I thought Dr. Janice Fitzgerald did an amazing job of it when she was giving the updates every day.
Okay. Peter, again, I would invite any of you to, if you have thoughts, to chime in on any of the questions that I put out there, but I'll start with you. Do we have a sense, now that we're a few years removed from COVID, of what worked and what didn't? I wonder if, I think a lot of people today wonder if lockdowns were worth it, in other words, in the final analysis.
Yeah, and it's hard to look retrospectively. I think what I appreciate about COVID was the world came together to fight a common enemy for a brief period. And we were all friends during that moment when we were trying to understand the virus, develop a vaccine, develop therapy. So that was unifying in a sense. In our field, COVID led to a huge increase in research funding and priority. We're still riding the wave of huge advantage of federal money towards research based on pandemic. Pandemic preparedness is hard because you warn people it's coming, but it doesn't come for some time. And then the warnings slowly get quieter and we take other priorities. And then the pandemic explodes and we may be underprepared. So I think the government of Canada right now has a big priority on pandemic preparedness. Let's notice the next virus quickly. Let's do science quickly as needed with collaboration around the world. How long will we continue to keep preparedness in our minds? 5 years, maybe 10 years. The other thing is that the next pandemic is probably earlier because of the way that the world is changing.
Okay.
Can I follow up there?
Absolutely, yeah.
Yeah, so great points made by everyone. And I think just following on Peter's last point there, I think, of course, we don't know, hindsight is 2020. That's the cliche, of course, more now than ever. But, right now we're looking at H5N1, right? This strain of flu that's around in some animals and stuff. And I honestly don't think that we would be paying as much attention to that 7 years ago. The common public might think, oh, that's, scientists are talking about it, but, it'll never happen. We now know, right? I think the biggest lesson in all this is we now know that the world can stop. And I, for one, didn't believe that could happen. When COVID started, I really thought, it's a coronavirus. This is one of the common cold viruses. Why are people making such a big deal of this, right? And I forgot that nobody had immunity against it. So even what I'd consider a wimpy virus in the virus world can stop the world because nobody had immunity against it. And once I realized that, then I realized, okay, this is actually, these lockdowns at the time, we can argue whether or not they were necessary, but at the time, there were people in parts of the world, there was mass death, right? And we had to do what we thought we had to do at the time. But again, I think the biggest lesson in all this is that something like this can happen any day, and it can really affect all of our lives for 5 years or more. And I do think that now we're a little more accepting of the idea that these threats are real and that they could pop up any day. So if there's one lesson we've learned, that's a positive one.
Okay, we have another note from a caller. It's an interesting one. What I've noticed, they write, is that doctors who speak publicly about vaccines rarely talk about the consequences of not being vaccinated. Aside from death, there's serious lifelong complications, possibility of brain damage, blindness, deafness. People need to hear about these risks. The media doesn't highlight them enough either. Natalie Bridger, I think as a doctor, we heard Josh Rash talking about how it was the positive message of all of us kind of working together for the entire community that was very convincing during COVID. As a doctor, are you obliged to read off the list of potential complications to people as well?
Yes, I think that's a really great point. Many people don't realize the impacts, the serious impacts that a lot of these vaccine preventable diseases can have on people, particularly children. And so when I'm encountering a family who's got questions about vaccines, I won't launch right into, litany of various problems that can happen. But a lot of people don't know that when you get meningitis, you can have hearing loss afterward. A lot of people don't know that. A lot of people don't know that when you have measles, you can get pneumonia, and a lot of 1 in 1,000 people suffer from neurologic consequences from measles. So I think that those kinds of conversations are necessary. There is a balance, though. You don't want to overwhelm people with facts and figures, but I think that there is a responsibility to talk about the risks of these vaccine preventable diseases, the real risks.
As you say, you don't want to be wagging your finger in the face of someone all the time.
Yes, absolutely, absolutely, and that's. I hope that that's not how these conversations go when people come to my clinic. I hope that it's more of a shared conversation and just a sharing of information, because that's you're not going to persuade anybody by wagging a finger and listing off all the different problems.
Go ahead.
I think we've forgotten what these diseases are really like. When we talk to our grandparents about what diphtheria was like and children were choking to death, what tetanus was like, we've generationally forgotten those things because they've been eliminated practically.
So there's no more living memory of it, shall we say. The last people who would have remembered these as being common diseases have passed on.
Yeah.
Okay.
If I could make a somewhat shameless plug here for my mentor, Dr. Rick Cooper, recently published a book called Only a Baby Gone. It's about child health and welfare in Newfoundland before Confederation. And if anybody wants a real grim, very painstakingly researched look at child health and welfare in the early 1900s in Newfoundland and Labrador, including all of these diseases we're talking about right now, that's an excellent read. And I think that gets to what Dr. Daly just mentioned. Our kind of lack of institutional memory can be reinforced with this. This is an excellent book for anybody who's interested in this topic.
Only a Baby Gone,
Only
right?
a Baby Gone, Dr. Rick Cooper, pediatric infectious disease specialist.
Dr. Cooper was in this studio not long after the book was published, a man who's very, very passionate about that topic.
Yeah.
And not afraid, did not mince words at all in talking about the way public health was several generations ago versus today, and how we don't truly appreciate it. Mm-hmm. Right.
Yeah. Yeah, and it's not, I mean, it's only one generation apart from us in Newfoundland. So I think that, it's important to know these diseases and know the difference that vaccines have made.
I wonder, where are we going in the future of vaccination for diseases that are known and perhaps as yet unknown or uncommon? John, I wonder, can you talk a little bit about technology and development of vaccines? Is the field changing? And are the standards changing? What's going on currently?
I think, like I mentioned, there's many more tools on the toolbox, and I think the COVID really the mRNA technology really opened up a new technology that we can really utilize to combat next unknown disease. And I think that the reasons that mRNA is such a powerful vaccine technology is because it's versatile. We can actually quickly able to design a new antigens with compared to other conventional methods. You need to take a long time to manufacturing a vaccine, but for the mRNA vaccine, the manufacturing phase is really short. So that's really kind of amenable to overcome these pandemic types infections, that you can actually design a new vaccine quickly. And the more that we learn now, the better we can actually make this vaccine safer. Different components, scientists is actively researching how to optimize or reduce any sort of side effect that people commonly experience. Something as simple as like the lipid envelopes to use to deliver this vaccine to people different components can actually reduce the side effect that you experience every day. I think some people do complain about the mRNA vaccine. When they actually get them, they give them a little fever or maybe knock them out for a day. I think some new formulations could actually reduce some of that. So we, as a vaccine field, I think there's a lot more innovations. There's a lot more research to try to improve the technology.
Are things happening more quickly, development taking place more quickly in part because of improvements in data processing or use of artificial intelligence, those technologies?
Yeah, I think that definitely is all this technology kind of come into effect. The AI helps to predict certain complications and antigen design. All these things kind of factor into them. And then the fact that our synthetic technologies are getting better to making more RNA molecule much faster, much more efficient, and so all these kind of come together. We see at the top it's just one mRNA vaccine, but there's a lot of research onto all sort of different aspects to come together to make it into a vaccine. So there's a lot of active research area to make it faster, better, and safer.
Rod Russell, do you think the fact that vaccination is much more of a prominent public conversation now than it used to be, is that reflected at all in the research that's currently being done?
Yeah, I think so. We've all lived through a pandemic now. We've all, faced that question of whether or not we wanted to get a vaccine, mandated or not, right? We all wondered how we felt about that. So I think there's a lot more, knowledge. There's a lot more interest. I don't know for sure, but I'm sure there's people looking now to, philanthropic efforts. People probably want to donate money specifically to the research that leads to life-saving cures like that. There's no doubt that at federal levels, the term One Health, for example, is a relatively new term, right? Years ago, our main health funding agency in Canada wouldn't fund studies on viruses that don't infect humans, whereas now we're broadening a little bit. So we're saying, okay, there are viruses in animals that could end up in humans, like we saw with COVID-19 or with SARS-CoV-2. So I think there's definitely an expansion of what we consider now as a threat and something that should be funded, and things that there should be research done on. So there's no doubt there's an expanded awareness now.
Okay, we're just about out of time here. I did want to throw out one question that I heard from someone anecdotally when they heard we were doing this show, which is, if I have a bad reaction to the shot, does that mean the vaccine is making me sick and should be avoided? Or is it just random, or should I have it looked at by a doctor? What do you think?
The vaccine response induces an immune activation. And so there are symptoms of fever or localized inflammation or pain. And that's part of how the vaccine works. We want that. We want the immune system to recognize that antigen or messenger RNA. So a bit of reaction after vaccine, I tell my patients, I'm glad you had that, because that shows me that your immune system is activating as I want it to.
Okay. Do you want to add to that?
Yeah, agree. I think that's most of these things are expected. I think if somebody said that they had an anaphylactic type of reaction, so tongue swelling, low blood pressure, that would be a different story, and that's exceedingly rare. That's so rare, and so most of the time it's these local reactions of the skin and maybe feeling a little bit rotten for a day or so, which are mild and self-limited.
Okay, that's a good sort of practical, down-to-earth question and answer to finish off with. And that about wraps it up for today. Rod Russell joined us on the line. Thanks so much for being part of the show.
My pleasure. Thanks for doing it.
Okay, and all the rest of you here in the studio, Peter Daly, Natalie Bridger, John Law, thanks so much for joining us.
Thanks for
Thank you for having us.
That is it for today's edition of The Signal. Just a reminder, if you missed the conversation, it is available on the CBC Listen app or on the CBC Newfoundland and Labrador YouTube channel. You can review the whole thing there, or you could pass it on to someone who you think might enjoy the show. If you have any thoughts about today, you can leave us an email, thesignal@cbc.ca, or you can send a voicemail. 709-576-5260 is the number to call. Coming up tomorrow, it is National Indigenous Peoples Day, or one day short of it. We'll hear Indigenous voices reflecting on what the day means, how they are gathering and celebrating. I'm Jamie Fitzpatrick. I'm sitting in for Adam Walsh. Thanks for joining us today.